Hello to each and everyone. I am Geneva Mea Costa Casido, taking this same major in agronomy. So first is to discuss the steps in scientific method with concrete examples. So I'm going to discuss first the 1 to 3 steps, then the 4 to 5 steps will be discussed by Mr. Warren John Amante. So let's start. So the first step is observation. The first step of the scientific method involves in making observation about the particular research or experiment. It means to notice what is going on through your senses. But specifically, we can define an observation as the act of knowing what is going on and recording what just happened. Just for example, you're observing a plant movement to animal behavior that will come up as your science project. So the second step of scientific method is question. After you've made your observation, it is the time you must formulate about what you have observed. You should be concise and clear of your question. Therefore, everyone knows what you're trying to solve. For example, you're doing your project on plants and you may want to know how plants interact with microbes to plants. So the question goes here. Is plant species inhibit bacterial growth? So that's all. And the third step in scientific method is hypothesis. Hypothesis is an idea that is suggested as an explanation for a natural event, a specific condition that can be tested through definable experimentation. It states the purpose of your experiment, the variables used, and the predicted outcome of your experiment. For example, is if the amount of the fertilizer is increased, the plant growth will increase.
Hi, good day. I am Orenjan Amante and I am discussing the steps number 4, 5, and 6. So, the fourth step is experiment. What is an experiment in scientific method? An experiment is a procedure designed to determine whether observation of the real world agree with the prediction of the hypothesis if evidence from experiment supports a hypothesis that gives the hypothesis more credibility. Example of the experiment's method. An example of the experiment is when sentence says gives rats a new medicine and see how they react, learn about medicine. An example of the experiment is when you try a new coffee shop but you not sure how the coffee will taste to conduct an experiment. So the fifth steps is analyze. What is analyze in scientific method? The next steps in the scientific method is analyze the data. Data analysis is the process of interpreting the meaning of the data we have collected, organized, and display in the form of the table or graph. What does analyze mean in a sentence? Sentence study the natural world through observation and experimentation. One process used to do this, the scientific method. The scientific method compares making an observation, forming, question, creating the hypothesis, experimenting, analyzing, and conducting an experiment. So the 6 steps is result. Result means the ending of the scientific story. A scientific experiment has beginning and end. The result of the simple and the end of the scientific experiment, what you found in the study. Why is scientific result is important. Publishing result of the research project in peer-reviewed journals, the scientific and the medical community to evaluate finding themselves in also providing instruction so that other research can repeat the experiment or build on the verify confirm the result. So that's all. Thank you.
Now let's proceed in the report on the fundamental tenets of scientific method with and its examples. The scientific method offers scientists a basic step-by-step procedure helping to ensure their experimental results are credible and useful. Understanding the essential principles of tenets of the scientific method can help you conduct experiments efficiently and effectively. In the book of Moses 2710, he enumerated the fundamental tenets of scientific method which has already begun in the early 1400s. So here are the following. Number one, source of information. This means that all recognized facts can be derived only from careful documented actions and controlled by experiment. In other words, any claims which come from priests or prophets or even scientists can be accepted automatically unless it is verified through accurate testing to produce proofs. Example of information sources may be observations, people, speeches, documents, interviews, academic journal articles, pictures, personal correspondence, experiments, or organizations. Number two, phenomena that can be studied. This entails that only tangible or something that can be touched phenomena and objects are studied, particularly heat, plants, minerals, and weather. It is a fact that magnetism or neutrons cannot be seen or felt, but instruments are invented to be able to detect them reliably. In simple words, whatsoever that cannot be observed cannot be studied. Scientific phenomena are occurrences in the natural and human-made world that can be observed and cause one to wonder and ask questions. For example, earthquakes, tsunamis, volcanic eruptions, tornadoes, or plant or other living and non-living things that can be touched or observed. Number three, constancy and universality. Physical forces that govern the universe are constant through time and any place. To elaborate, experiments that are done at one time and place should give the same results, even if it is repeated at a different time and place. This did not allow us to design future experimentation and to make predictions of what the outcome should be. If the experiment does not get the predicted outcome, it must be concluded that our theory was incorrect, not that the necessary forces of the world have unexpectedly changed. And the tendency to perceive objects as unchanging despite changes in sensory input. People tend to perceive objects as constant and unchanging despite changes in perspective, lighting, color, or size. For example, a person viewed at a distance produces a smaller image on the retina that same person up close, but the perception of the size of the person is constant. The ability to perceive objects as having constant properties despite variations in how they are perceived eliminates the need to reinterpret those objects when they are perceived under different conditions. So when we say constancy, it is the quality of being faithful and dependable. Make sure that any physical forces of data or data gathered are constant through time and place. Number four, the basis. Cardinal basis of the scientific method is skepticism. To simply put this, skepticism means doubt. This is the basis of never being assured of the conclusion. It is also means that always be prepared to examine new evidence. Basis for research is a type of scientific research with the aim of improving scientific theories for better understanding and prediction of natural and other phenomena. For example, descriptive research, experimental research, or field study.
Give a clear comparison of scientific theory and scientific law. So the most basic difference between scientific law and scientific theory is as simple as the difference between what and why. A scientific theory, it explores why. A theory is about underlying causes, seeking to explain the reason a phenomenon occurs. The focus of a theory is to provide a logical explanations for things that occur in nature. Whereas, a scientific law focuses solely on describing what. A scientific law provides a description of a directly observable phenomenon. It describes what will or is expected to happen in a certain set or a circumstances. Some of the clear comparison between scientific law and scientific theory that we can easily understand. So, a scientific laws based on unalterable facts. When we say unalterable facts, is not unable to be changed. While scientific theories is only based on observation or their investigation. A scientific laws is proven, while scientific theories proven but still testable. A scientific laws has an evidence and results, while a scientific theory is only an evidence, there's no results. Then, a scientific laws states that something will happen under certain conditions, as I said earlier. While the scientific theories attempts to explain why something happened. A scientific laws can be represented by mathematical statement, whereas scientific theories no mathematical statement. And some of the examples of scientific laws are Newton's laws and law of inertia. So these laws are based on unalterable facts. There is evidence and results proven and represented by a mathematical statement. Where some examples of theories, the theory of relativity and Big Bang theory. So these theories are based on observations. They're proven but still testable. We have only an evidence but there's no results. And there's no mathematical